We've just talked about a geometric way of representing vectors. However, we can also represent vectors algebraically. Let's see how. An algebraic vector v is represented as v equals a comma b, where a and b are real numbers, or scalars, are called the components of the vector v. If v equals a comma b is an algebraic vector with initial point at the origin O and terminal point at p equals a comma b, then v is called a position vector. So the position vector has the initial point always at the origin. So here's an example of what a position vector looks like for the vector v equals a comma b. Notice the initial point is at the origin, and the terminal point is the point p equals a comma b, the same as the components of the vector. By the way, the scalars a and b are called the components of the vector. So suppose that v is a vector with initial point p1 equals x1, y1, not necessarily the origin, and terminal point p2 equals x2, comma, y2. If the vector v is equal to the directed line segment p1 to p2, then v is equal to the position vector. We take x2 minus x1 and y2 minus y1. Remember, the order is going to be important here because the initial point is p1 and the terminal point is p2. For example, suppose we want to find the position vector of the vector v equals the directed line segment from p1 to p2. To find the position vector v, we compute the difference between x2 and x1, so 4 minus negative 1, and then y2 minus y1. So 4 plus 1 is 5, 6 minus 2 is 4, so the position vector is 5, 4. What we want to do now is look at the graph comparing the directed line segment from P1 to P2 with the position vector v. What you should notice is that the vectors are the same magnitude. In other words, the line segments are the same length, and they're in the same direction.